Section C, also known as Module 3, and Module 3 constitutes of limits and continuity, differentiation, and integration. Without further ado, let's get into it. So, start with question 5. Question 5 says, a function f of x is defined as f of x is equal to f of x is equal to x plus 2 and x squared. It's equal to x plus 2 when x is less than 2, and it's equal to x squared when x is greater than 2. And it says, find the limit as x approaches 2. Now the limit as x approaches 2 of f of x, the limit has to be equal on both sides. So it has to be equal to the limit as x approaches 2 from the positive side of f of x, and it should also be equal to the limit as x approaches 2 from the negative side of f of x, or from values less than 2. Now we need to check if left-hand limit is the same as right-hand limit. Now, when you plug in 2 here, 2 plus 2 is 4. Plug in 2 here, 2 squared is 4. And so the limit as x approaches 2 of f of x is 4. Right? So if you want to put a concluding statement to say, therefore, the limit as x approaches 2 of f of x must be equal to 4. Nice and easy. Soft. That's our concluding statement. Now it says determine if whether f of x is continuous at 2. Now f of x is clearly not continuous at 2. F of x is discontinuous at x equal to 2 since f of 2 is undefined. All right, since f of 2 is undefined, the function is discontinuous, so it's not continuous. Nice. So finish part A. Let's have a look at part B now. Part B says y. It says y is equal to x squared plus 2x plus 3, and all of this is divided by x squared plus 2, x squared plus 2 all cubed. So that's y, and show that dy by dx is that thing there. So now to do this, we're going to be differentiating. So dy by dx is going to be equal to, when you're differentiating, you start with the bottom. So you get x squared plus 3, x squared plus 2 all cubed. So you start with the bottom times the differential of the top. The differential of the top is 2x plus 2 minus the top. And the top is x squared plus 2x plus 3 times the differential of the bottom. And the differential of the bottom is you carry down the power, needed a little more space, carry down the power, you subtract 1 from the power, so you get x squared plus 2 squared times the differential inside the bracket. The differential of x squared is 2x. So you multiply it by 2x. And all of that is being divided by the bottom square. So it's being divided by x squared plus 2 raised to the 6th power. All right, so hence dy by dx, is equal to, let's expand this across. Now, we have to, first thing, I'm not going to expand this across. This will be too difficult, or it will take too much time. So instead, I'm going to factor out x squared plus 2 squared. I'm going to factor out x squared plus 2 squared. And in here, I'm going to be left back with an x squared plus 2 going to be left back with an x squared plus 2 that is then going to be multiplied by 2x plus 2 times minus, over here I'm going to be left back with x squared plus 2x plus 3 times 6x. I'm left back with x squared plus 2x plus 3, and all of this is left back is multiplied by 3 times 2x, which is 6x. Now in the denominator, I'm going to factor out a x squared plus 2 all square as well. Factoring out x squared plus 2 all square. And what I'm going to left back with is a x squared plus 2 being raised to the 4th power. All right, and so what happened? Then this x squared plus 2 all square cancels. This x squared plus 2 all square, those cancel each other. And so what I'm left back with now is that dy by dx so we get left back with dy by dx. And this is now going to be equal to, let's expand out this numerator. Expanding out this numerator, we're going to get x squared times 2x, which is 2x squared. X squared times 2, which is plus x squared times 2x is 2x squared. X squared times 2x is 2x cubed. X squared times 2 is 2x squared plus 2x squared plus 4. And it is now subtracting. Now x squared times 6x, that's subtracting 6x cubed. Then 6x times 2x That's subtracting 12x squared. Then 6x times 3, it's subtracting 18x. And this is all being divided by your x squared plus 2 to the 4th power. All right, so what does this work out to be now? Now 2x cubed minus 6x cubed, that's going to work out to give us minus 4x cubed. All right, then your 2x squared plus 2x squared minus 12x squared, that's 4x squared minus 12x squared, which is minus 8x squared. This works out to be minus 4x cubed minus 8x squared. Then you're going to have 4, you have minus 18x. Oh, some error was made. X squared. 2 times 2 is not 2x squared. 2 times 2 is 4x. Oh gosh, this was a big mistake. Mistake was made here. This should be 4x. Giving it away. Don't give it away. This 2 times this 2x is 4x. And so this is how we get now the 2x squared minus 12x squared is now minus 10x squared. Then our 4x minus 18x is minus 14x plus 4. And look there, look there, look there. We get what we're supposed to get now. And all of this is divided by x squared plus 2 to the 4. And so we're perfectly fine now. All of this is divided by x squared plus 2 raised to the 4th power. So we're nice. This is dy by dx. Nice. So this is the solution. Proven. Soft. Now let's look at part C. Part C gives us that x is equal to 1 minus cos 3 theta or 1 minus 3 cos theta and y is equal to sine 2 theta. And it's a find dy by dx. So first thing is you're going to find what is dx d theta. Dx d theta is equal to, we differentiate, why I'm writing t should be theta. So dx d theta is going to be equal to, when you differentiate 1, you get 0. When you differentiate cos, you get minus sine. So it becomes 0 plus 3 sine theta. And then when you differentiate y now, dy by d theta, that's going to be equal to dy by d theta. When you differentiate sine, you get cos. So you get 2 cos theta. All right, nice and easy. So what is left to do? The only thing that is left to do is to find dy by dx. So let's go ahead and find dy by dx. Finding dy by dx, dy by dx is equal to dy by something times something over dx. That something in this case is d theta. So dy by dx is dy by d theta times d theta dx. So what that then means is that dy by dx is dy by d theta, which is 2 cos theta multiplied by d theta dx. But we know dx d theta, so d theta dx is 1 over this. So it's multiplied by 1 over 3 sine theta. And so this is going to work out to be cos over sine is cot. So it works out to be 2 over 3 cot theta. That's dy by dx. Nice and easy, soft. Nice. Finally, we're looking at this now. It says that diagram below shows the curve y equal x squared plus 3 and the line y equal 4x. Determine the coordinates of P and Q where the line and the curve intersect. So if we want the point where the line and the curve intersect, finding the point of intersection, we substitute the line into the curve. So that's how we're going to do. Substitute the line into the curve and we solve them simultaneously. So let's go ahead and do that. So we have y is equal to x squared plus 3 and y is equal to 4x. So if y is equal to x squared plus 3 and y is equal to 4x, then that implies that 4x must be equal to x squared plus 3. And if 4x is equal to x squared plus 3, then that implies that x squared minus 4x plus 3 equals 0. And if this is so, then we can factorize this. So this is baby quadratics, this is CSEC, this is grade 9 or grade 10. So we have x, 3 and 1. Signs are the same, both of them negative. So what we're getting is x is equal to 1, or we're getting x is equal to 3. Now, since x is equal to 1 and y is 4 times x, then in this case, y is equal to 4 times 1, which is 4. And in this case, y is equal to 4 times 3, which is 12. So go ahead and write it down. Tell them what is P and tell them what is Q. So you can tell them that P is 1, 4, and the Q is the point 312. Go ahead and tell them that, man. Nice. Now the second part of the question. The second part says calculate the area shaded. Now to calculate the area shaded, I like to call area shaded AS. The area shaded is equal to the area under the line. So it's equal to the area under the line minus the area under the curve. That's going to give us the area shaded. The area under the line is the integral from P to Q. The x value from P to Q is the integral from 1 to 3 of the line, and the line is 4x minus, so it's integral from 1 to 3 of 4x dx minus the integral of the curve, which is from 1 to 3 of the curve, which is x squared plus 3. Now, many persons would go ahead and just want to combine it as one integral. You can do the same, combine it as one integral to say we're finding the integral from 1 to 3 of 4x minus x squared minus 3. You can do that and combine it. Combining them, what we're going to get is that the area shaded is equal to, when you integrate, you add 1 to the power, so you get 4x squared divided by 2 minus this now x cubed over 3 minus 3x squared, and we're integrating from x being 1 to x being 3. All right, so go ahead, substitute x equals 3 in the equation and see what we get. So we're going to plug in x being 3, 4 over 2 is 2, and so we get 2 times 3 squared minus 3 cubed over 3 minus, why does this have a square right here? Let me see, add 1 to the power 2 divided by the power minus, add 1 to the power 3 divided by the power 3 minus 3x. This shouldn't be a square. Where does 2 come from? I did not put it there. I don't remember putting that there. Minus 3 times 3. Then you subtract. When you plug in 1, you have 4 times 1 square over 2. That's 4 over 2, which is 2. Minus plug in 1, you have 1 over 3. Minus plug in 1, you have minus 3. And then you work that out now. Put all that in a calculator. 2 times 3 squared minus 3 cubed over 3 minus 3 times 3 minus 2 minus 1 over 3 minus 3, and you get 4 over 3. So the area is 4 over 3. And remember, area is in units square. So the area is 4 over 3 units square. Nice and easy, soft. Now we're at the final question of the paper. And the final question of the paper, we have right here, question number 6. It says that by using the substitution, u is 1 minus x, integrate x times 1 minus x squared. So I like to call my integrals I. So let I be equal to the integral from, well, it's an indefinite integral, the integral of x times 1 minus x squared I'm going to use substitution. Using u substitution, we're calling u 1 minus x. So if u is 1 minus x, then du is equal to -1. Right? And now if and du is -1 dx. And so if this is u and this is du, then if this is u, then this is telling us that x is actually 1 minus u. And so good. So I'm going to rewrite this integral as the integral of minus x times 1 minus x squared minus dx. You might wonder, why did I put a minus dx? I put a minus dx so I can substitute du minus dx here and the minus on the outside. Now I can substitute. This is now equal to the integral of minus dx is du and 1 minus x squared. This is now u squared, and it is now x is 1 minus u, so I have 1 minus u being multiplied by u squared, and then minus dx is du. Of course, I had a minus out here, and so this works out to be the integral of now u squared times 1 is u squared minus u cubed. So in reality, it is just u cubed minus u squared du. So all I have to do now is add 1 to the power. So I get u to the 4 divided by the power of 4 minus add 1 to the power u cubed divided by the power of 3 plus some constant k. But then what was u? U was 1 minus x. So this works out to be 1 minus x being raised to the 4th power divided by 4 minus 1 minus x divided by 3 raised to the 3rd power plus k. And that's the integral. Nice and easy. So now let's look at the second part. The second part of the question, part 2, it gives us that f of t and g of t. It says f of t is equal to 2 cos t, and it tells us that g of t is equal to 4 sine 5t plus 3 cos t. Nice and easy. Now it's f of t and g of t. So it says show that the integral of f of t plus g of t is the integral of f of t plus the integral of g of t. So let's work out this first. So first I'm going to work out what is f of t plus g of t. All right. And so f of t plus g of t, that's equal to, adding them together, I would get 4 sine 5t plus 5 cos t. All right. That's f of t plus g of t. And so the integral of f of t plus g of t, integral of f of t plus g of t, the integral of f of t plus g of t is just equal to the integral of this. It's equal to now the integral of 4 sine 5 theta, integral of 4 sine 5t plus 5 cos t. I don't know why I always say theta when it is t. And when it is theta, I'm saying t. My bad. So let's work this out. Working this out, getting when you integrate sine, you get minus cos. So you get minus 4 cos minus 4 cos 5t divided by the differential of 5t, which is 5. But then when you integrate cos, you get sine. So you get plus 5 sine t plus some constant of integration. Let's call it k. So that's the integral of f of t plus g of t. Now let's work out now what is the integral of f of t, and then work out the integral of g of t. I'm going to do that part in red. Now, the integral of f of t plus the integral of g of t, that's going to be equal to, now the integral of f of t, when you integrate 2 cos t, what are you going to get? When you integrate 2 cos t, you get 2 sine t. You get 2 sine t. Plus, when you integrate g of t, when you integrate g of t is 4 sine 5t, 3 cos t. When you integrate 4 sine t, when you integrate sine, you get minus cos, so it's going to work out to not be plus, but minus 4 cos 5t over 5, and then plus 3 cos t plus 3 cos t, and when you integrate 3 cos t, you get 3 sine t plus some constant c. All right, but then now that 2 sine t and that 5 sine t, 2 sine t and 3 sine t give us 5 sine t. So we get 5 sine t minus 4 cos 5t over 5. Minus 4 cos 5t over 5. Plus their constant c. Clearly they are the same. Alright, so just to conclude around here, hence, it is definitely seen that the integral of f of t plus g of t hence the integral of f of t plus g of t, when you do it like that, the integral of f of t plus g of t is just equal to the integral of f of t plus the integral of g of t. I know I left off my dt, you don't ever do it, but yeah, nice and easy. So proven, soft. Nice. So there you have it, proven. Now let's go to the next part of the question. The next part of the question says, a sports association is planning to construct a running track in the shape of a rectangle surmounted by a semicircle, as shown in the diagram below. The letter X represents the length of the rectangle and R represents the radius of the semicircle. And the perimeter of the track is 600. Show that R is 600 minus 2x over 2 plus pi. So let's do this question now. So you have a rectangle. I'm just going to draw a rectangle for us. You have a rectangle and you have a semicircle. How can I draw a semicircle? You just right. That's a semicircle, and the radius of the semicircle is r. The length is x. Now, if the length is x, then that means that down here is also x. If the radius is r, that means the diameter is 2r, and so this side is also 2r. So what does that tell us? The perimeter is going to be equal to x plus 2r plus x plus the perimeter around half a circle, which is pi times r. So the perimeter is actually going to work out to be 2x plus 2r plus pi times r. Nice. But right here, so if the perimeter is this, then perimeter, which is 600, so it's really 600 is equal to 2x. We can factor out r to 2 plus pi, and then now we're good. Now you can subtract 2x from both sides and divide by 2 plus pi to get that r will be equal to 600 minus 2x divided by 2 plus pi. That is r. Nice and easy. Soft. So proven. Now let's look at the next part of the question. The next part of the question goes by asking, it says, hence. I want to pause when it says hence. Hence, meaning we have to use this knowledge somewhere, some way, somehow. It says, hence, determine the length of x that maximizes the area enclosed by the track. So once it's talking about area, I know that the area of that track, the area of this track is going to be equal to the area of the rectangle, which is length times width. So the length is going to be x times 2r, which is 2rx. That's the area of the rectangle, plus area of the semicircle, and area of the semicircle is a half pi r squared. Nice. So that's the area, and next thing I'm going to do is substitute for r. 600 minus 2x over 2 plus pi. That's dangerous. So substituting for r, I'm going to get 2 times 600. I'm just going to do it in one step. Oh boy, Lord help me. 2 times x times 600 is 2 times 600 is 1200 x minus 2x times 2x with 2x times minus 2x 2 times, that becomes 4x squared over 2 plus pi. So I worked out this side first, plus a half pi r squared. Oh gosh, I'm gonna have to square this. Oh gosh, what I'm gonna do is I'm gonna write it as plus a half pi r squared is gonna work out to be r squared. Let me try to square the numerator first. Square the numerator first would be 600 squared. 600 squared Oh God, that's a big number. So I'm just going to write it as 600 minus 2x all square over 2 plus pi all square. Nice. So let me just write it together as one final statement now that A is working out to be. Just writing it one final time. I'm going to pretty it up. Prettying it up, I can write it as A is equal to 1 over 2 plus pi multiplied by, that's now 1200x minus 4x squared. 1200x minus 4x squared just prettying it up, and this part now I'm going to pretty it up as a half pi times 2 plus pi squared. I'm just going to write this as plus a half pi, that's really pi over 2, and then this 2 is multiplied by, I'm going to change the denominator to 2 times 2 plus pi all squared. So it's 2 times 2 plus pi all squared. And all of this here is being multiplied by 600 minus 2x all squared. Nice and easy. Okay. Now it wants us to find the value of x that maximizes the area. So we need to find dA by dx and set it equal to 0. So dA by dx is going to be equal to, when I differentiate this, I'm going to get 1 over 2 pi, 2 plus pi times, when I differentiate this now, I am getting differentiate 1200x, I get 1200 minus 8x plus oh boy, differentiating this now, I'm going to carry down the power. Now carry down the 2, and then this 2 cancels this 2, carry down the power. So I get pi over 2 plus pi all squared. Okay. Carry down the power. Subtract 1 from the power to get 600 minus 2x times the differential inside the bracket, which is negative 2. Instead of doing that negative 2, on the outside, I'm going to rewrite this as minus 2 pi. And then for the area to be maximized, we set this equals 0. So now we need to solve this equation for x. Solve this equation for x. To solve this equation for x, we can multiply through by 2 plus pi all squared. Multiplying through by 2 plus pi all squared, and you get 2 plus pi times 1200 minus 8x minus 2 pi times 600 minus 2x. And now this look normal now. Now we can solve for x. Thank you, God. Now it is normal. So go ahead and solve for x now. Expanding them across. I'm going to get 2 times 1200 is 2400 minus 2 times 8x is minus 16x plus 1200 pi and this 2 times this is this 2400 minus 16x plus 1200 pi minus 8x pi minus 1200 pi minus 4 minus and minus become plus, so it becomes plus 4x pi equals 0. Now look what I'm going to do. I am going to underline this right here, this 1200 pi and this minus 1200 pi cancel each other. Okay, and all we need to do is group our x terms. If we group our x terms, or even if we factor out the x, if you factor out the x, alright, factoring out the x, you're gonna have, and you don't even need to do that yet, because this 4x pi and this minus 8x pi is minus 4x pi. So what we're really getting is 2400 minus 16x minus 4x pi is equal to 0. All right. Now we can solve for x. We can divide through by 4 to get 600 minus 4x minus, we divide it through by 4, and so this is x pi is equal to 0. So then what does that tell us? That is telling us that we can factor out x right here, and we're going to get minus 4 minus pi minus 4 minus pi, and that is equal to negative 600, because I bring over 600 over here. And so finally we can divide both sides now to get x is equal to negative 600 over, we divide it by negative 4 minus pi, and so the negatives are going to cancel each other, and so the reality is x is equal to 600 over 4 plus pi. That's the value for x that maximizes the area. X is 600 over 4 plus pi. How do I know that? I know that because d2a by dx squared is automatically negative. d2a by dx squared for this x value is going to be less than 0. I automatically know that. How do I know that? From right here. Minus 8x. You're going to get a negative number. And so this is the value for x that maximizes the area. That is the value of x that maximizes the area. Nice. 600 over 4 plus 5. Now the last part now, it says let y be equal to minus x sine x minus 2 cos x plus ax plus b. And it says show that the second derivative is x sine x. I'm going to do it fresh around here. So y is equal to minus x sine x minus 2 cosine x plus ax plus b. Now, if you see y and they ask you for y prime is the first derivative. So we're going to differentiate x sine x by keeping the first. Using product rule, we keep the first. Then we differentiate sine x to get cos x. Plus, we keep the second sine x. Then we differentiate the first to get negative 1. Then we differentiate cos, we get minus sine. So we get plus 2 sine x. Plus, we differentiate ax and we get a. Plus, when we differentiate b, we get 0. So that is y prime. Okay, so in reality, y prime works out to be minus x cos x minus sine x plus 2 sine x. That minus sine x plus 2 sine x is really just plus sine x plus a. Now we need the second derivative. The second derivative is we use product rule again to keep the first times the derivative of the second. When we differentiate cos, we get minus sine x plus keep the second, which is cos x, times the derivative of the first, which is minus 1. Plus, when you differentiate sine, you get cos x. Then when you differentiate a, you get 0. So the second derivative, y double prime, is equal to x sine x, then cos x minus cos x plus cos x. So hence minus cos x plus cos x is 0. And so y double prime is equal to x sine x. So prove it. So that's proven. Soft. Nice. Now that we prove it, we're nice. The second part now. The second part is a hence. Anytime it's a hence, you're going to utilize that. It says hence. Hence, determine the specific solution. All right. Now, hence, y double prime is x sine x. So hence just mean that this is y. All right. So hence, we know that y is equal to minus x sine x minus 2 cos x plus ax plus b. So all we're going to do is plug in when x equals 0 and y is equal to 1. What we're getting is 1 is equal to x is 0, so that part works out to be 0, minus 2 times the cosine of 0 plus ax, but what is ax? A times 0 plus a times 0 plus b cos of 0 is, I believe that's 1. Cosine 0, yes, the cosine of 0 is 1. So we're getting 1 is equal to minus 2 plus b, and so we transpose for b by adding 2 to both sides, and so b equal 3. And that's when x equals 0. Next we need is when x equals pi. When x is equal to pi, it tells us that y is equal to 6. And so when x is equal to pi, y is 6. So 6 is equal to, the sine of pi is 0. The sine of pi is 0. So we can just put 0 minus 2 times the cos of pi plus a times x is pi plus b, but we found that b is 3. So we're going to subtract 3 from both sides to get 3 is equal to, what's the cos of pi? The cosine of pi is minus 1. That works out to be 2 plus a times pi, and we need a. And so divide through by, subtract 2 first, so 1 is equal to a times pi, and then divide both sides by pi, and so a is equal to 1 over pi. A is 1 over pi. But of course, the question didn't care about all of this long work, you know, they just want the specific solution. So the specific solution is y is equal to minus x sine x minus x sine x minus 2 cos x plus ax, where a is 1 over pi, so it's plus 1 over pi times x plus 3. That takes care of 2013. So this paper easy? Nice. So make sure to just subscribe, all right? And really hope this video was really helpful, and good luck prepping for your exam.